Hello, this is Mr. Buffington, and in this lesson we're going to be looking at the distance equation. Finding the distance between 2 points on a graph is basically what we're going to be doing today. So, how might you find the distance between 2 points? If we're given these 2 points, what might be some ways that we could possibly know how far it is from -2, 3 down to 1, -1? Well, I guess we could measure it. We could grab some kind of measuring device. We could estimate. We could guess. Just tell me. Well, I'm going to show you a way that we can find the distance between these 2 points. So, between those points, there are a couple of things. First off, if we just go ahead and draw some lines here, maybe that'll look familiar. This one's 4 units, this one's 3 units, and this one is solve me. The distance between those 2 points is the hypotenuse of a right-angled triangle. That's pretty awesome, because we know how to discover the hypotenuse of a right-angled triangle. We use the Pythagorean theorem. A squared plus b squared is equal to c squared. Or in other words, when we rearrange it, our distance of the hypotenuse is the square root of a squared plus b squared. So let's go ahead and plug those values in. 4 squared plus 3 squared, 16 plus 9, square root of 25. Our distance is 5 units, whatever that measurement is up there. Okay, that's how we calculate the distance between 2 points. We use the Pythagorean theorem when we basically have ourselves a triangle. Now, what if we're not given those distance? We actually don't even need a graph, but the distance from up and down is the change in your y values, y2 minus y1. And our y2 value is -1, and our y1 value is 3. So -1 minus 3 equals -4. It's a distance, it's a measurement, so we're going to make it a +4. Doesn't really matter in our equation later on, but it is a distance, so it's nice to think of it as a positive number. And we knew that before, right? We knew that that was a length of 4 units. But that's mathematically how we would find it, y2 minus y1. The distance of this side of our triangle is our x2 minus x1, which is 3. And we saw that in the last slide as well. I kind of gave you that information. I said, 3 units, 4 units. But this is how you would actually calculate it. y2 minus y1 is one of the sides of the triangle, and x2 minus x1 is the other side length of the triangle. That information will help us so we never need to look at a graph and draw a triangle again. Instead, we can just use this overly complicated looking equation. Now, I know it does look overly complicated, but it's actually not so bad. This is one of the side lengths of the triangle squared plus the other side length of the triangle squared, and we add them together, take the square root. We're using the Pythagorean theorem to find the distance between 2 points. Also, just a quick note, another reason that it doesn't matter if it's negative, like -4 in the previous example, was because we're going to square it. So let's say when I subtracted it was my y values. I subtract my y values and I get -4. -4 squared is the same thing as +4 squared. So when you get negative answers, it really does not affect the equation at all. Okay, so that's just a note, and I'll show you that in the next 3 examples that we'll see. Let's do it. Let's use this equation. Find the distance when you're given 2 points. So the point that we're going to be working with, 1, 3, and 7, 11. We're going to use our distance equation. We'll plug point 1 in for x1, y1. Then we'll plug point 2 in for x2, y2. So it'll look something like this. 7 minus 1 squared plus 11 minus 3 squared. That'll give us 6 squared plus 8 squared, 36 plus 64. Let's move over to here. Our total distance is 100, the square root of 100, which is a distance of 10. Now, again, when we take the square root of 100, normally we say plus or minus the square root of 100, but because we're measuring distance, we're only measuring in positive numbers. So you can't say the distance is -10 units. That doesn't make sense. Our distance is going to be measured in positive numbers always. All right, and that's how we solve this. Let's do two more examples. This one with some negative numbers. Find the distance between -1, and 11, 4. Well, we're going to do exactly the same thing. Our x1, y1 values are going to go right in there. Our x2, y2 values are going to go right in there. This is what happens when we have negative numbers. We still leave the subtraction symbol, but it becomes 11 minus -1, because -1 is our x value from point number 1, and then 4 minus -1, again -1 being the value, our y value from point number 1. Whenever you have these minus negatives, you change them into positives. So really this is like saying 11 plus 1 and 4 plus 1, which gives us 12 and 5. Squared, 12 squared is 144, 5 squared is 25. Let's move over to here. For the square root of 169, again, we are only working in positive numbers, in other words, the principal square roots, so our distance is 13. That's the distance between point 1, -1, -1, and point 2, 11, 4. Now, in my final example, I'm going to use pretty much all negative numbers, and you'll see you can still end up with a positive distance between them. Let's go ahead and plug those values into our distance equation. Our x1, y1 goes there and there. x2, y2 goes into there and there. So our equation looks really long. -12 minus 4 squared plus -17 minus -2 squared. And this is going to be a little bit complicated if you don't know the rules for adding and subtracting positive and negative numbers, which hopefully is kind of a prerequisite to being able to do this. But -12 minus -4 is the same thing as -12 plus 4, which would give you -8. -17 minus -2 is the same thing as -17 plus 2, which would give you -15. When you square those numbers, they become positive. -8 times -8 is positive 64. -15 times -15 gives you positive 225. Now we're going to go up here, add those numbers together, gives you 289. The distance is 17. The square root of 289 is 17. So that's the distance between these 2 points. Alright, so that's how to use the distance equation. I showed a little bit at the beginning of why it works. It's the Pythagorean theorem, but this is how to use it as well. I hope that lesson was helpful for you. Here is your Common Core Anchor and Pennsylvania eligible content, and also the distance equation for you. Hope that was helpful. Have a great day.